We're looking at the morning review for 5.4, 5.5 quiz. All right, so this is here I just have log properties spelled out that we can use, and then just a review over the derivative rules that are relevant for these two sections here. So just as a reminder, derivative rules for ln of u is u prime over u. Log base a of u, we have to adjust for the fact that this is no longer natural log. So to make that adjustment, we go through change of base, and it becomes 1 over ln of a, and then the rest of the rule looks the same, u prime over u. The rule for e to the u is just e to the u times u prime, and then if it is a base other than e raised to the u, then we have to adjust for the fact that it's not natural log, go through a conversion. So we have natural log of a, and then the rest looks like e to the u, where we just take the original function, in this case a to the u, times u prime. All right, when we're dealing with natural log functions or log functions, and we're trying to find the derivative, a lot of times we want to see if we can expand using some log properties so that the derivative procedure will be a little bit easier for us. So in this case, if we can split this up into individual terms, since this expression is inside the natural log function, so if we can maybe use a combination of power property and quotient property, then we can expand this into smaller portions and then find the derivative for each. All right, so expanding here, I'm going to rewrite the numerator as parentheses raised to the 3/4, and then I'm going to apply quotient property. So I know that natural log of a over b is natural log of a minus natural log of b. And along the way, I'm going to also distribute the coefficient 2 through the expression. All right, so now we have an equivalent expression. It's just that it's going to be a little bit easier to deal with rather than having to go through a messy derivative rule if we're trying to find the derivative from this point. All right, we can do a little bit more here. If we see we have exponent of 3/4, we can bring that down in front. Not using power, we're not doing any derivatives. We're just using the power property for logs, since this is still within the log expression. So the 3/4 come down in front. We're just simplifying. Now we're down to, this becomes 3/2 natural log of 3x minus 2x to the 4th. And now everything is expanded. We have a relatively easy rule to apply to find the derivative. So we can simply apply the rule for natural log of u. So natural log of u becomes u prime over u. So the derivative u prime, 3x becomes 3. Negative 2x to the 4th becomes negative 8x cubed all over u, minus u prime over u again. So 2x cubed becomes 6x squared over 2x cubed. And then we can just try and simplify as much as we can and then express our derivative. All right, number 2. We have x cubed times e to the 5x squared plus 3x. Notice that these are two separate terms, two separate variables. We have x cubed and we have e to the x squared. So we have to go through product rule. So to go through product rule, f prime g plus f g prime. So f prime, x cubed's derivative becomes 3x squared, and we keep the g function plus f times g prime. So the derivative for e to the u is e to the u times u prime. So 5x squared becomes 10x, 3x becomes 3. And we essentially have our derivative. I just went ahead and looked for common factors on either side of the plus sign. I can take out x squared e to the 5x squared plus 3x from both terms, and then that leaves me with 3 plus 10x squared plus 3x. Right, number 3, we have another log expression. So maybe we can try and expand a little bit. So if we try to expand, we can write this as x minus e to the x raised to the 1/2. And I just went ahead actually and applied the rule for log base a. So log base a is 1 over ln of a times u prime over u. So 1 over ln of a, my a is 8, so ln of 8 goes in the denominator, and then my expression is just natural log of x minus ex to the 1/2. So I'm just rewriting this expression as a change of base, and now I can jump into the derivative rule. So the derivative rule, actually I'm going to continue to simplify here, bring down the 1/2 in front, and now we can, after we simplify a bit more, now we can apply the derivative rule for ln of u, which is u prime over u. So u prime, so x becomes 1, e to the x stays e to the x, all over x minus e to the x. Okay, number 4. Notice that, again, we have two expressions, both separated by, related to one another by multiplication. So we have to go through product rule. So f prime g plus f g prime. Okay. Okay, so I actually expanded this out a little bit using change of base. I made this natural log of 2 minus root x over natural log of 10 to rewrite the problem. Okay, and now I can apply the rule for derivatives using product rule. So f prime, so 2 to 3x, a to the u becomes natural log of a times a to the u times u prime. That's f prime, and then the g function is the original here, plus the original f function, so 2 to 3x times g prime. So the derivative for this expression, 1 over ln of 10 is just going to be a coefficient. We should have to take care of the u prime over u under natural log. So the derivative for 2 minus root x is going to be negative 1/2 x to the negative 1/2, because 2 goes away. We just really take the derivative of the square root of x all over 2 minus root x. And it's a little bit messy here, but we just try to simplify as much as we can. And here's my f prime expression. Okay, number 5. We have log base of 2 root 1 minus 3x all over x minus 5x squared. And I went through change of base, made it natural log of a over natural log, or natural log of u over natural log of a. Pull that out in front, and then rewrote my expression using rational exponents, and then continue to simplify, because here natural log of a over b, I can go through quotient property. So natural log of a over b is natural log of a minus natural log of b. So once I have that, then it's a lot easier to find the derivative from this point on. So natural log of u is u prime over u, natural log of u is u prime over u, and then here's our f prime. All right, number 11, we have 11 raised to an exponent. I can rewrite it as 11 raised to the parentheses to the 1/3. Now this is in the form of a to the u, so we want to apply the derivative rule for a to the u is natural log of a times a to the u, which is the original function, times u prime. So we have natural log of a value is 11, the original function, so 11 raised to the cube root, and then finally the derivative of the exponent. So the derivative of the exponent, we have to go through chain rule. So bring down the 1/3, keep the parentheses, subtract 1 from the exponent. So 1/3 minus 3 over 3 is negative 2/3 times the inside function's derivative. So 4x becomes 4, 5x cubed becomes 15x squared, and then 3e squared, this doesn't become 6e, this is just a constant. So the derivative of a constant will go to 0. So make sure you keep in mind that e and pi are simply numeric values and they are not variables. So any derivatives that involve just e or just pi will just go to 0. All right. Okay, so after we simplify a bit more, we can bring the negative exponent, resolve the negative exponent by bringing it down to the denominator, and then here we have our f prime.